Some other examples of boost. Speed of sound in still air is 340 meters per second. If the wind is blowing at 30 meters per second and you shout at someone, the sound will travel at 370 meters per second towards them. Or 310 meters per second if the wind's blowing towards you. You can throw a baseball at 80 miles per hour at the fastest, and you're standing on the bed of a pickup truck going 60 miles per hour forward. Don't do this. You can pitch the ball forward. It will actually go 140 meters per second relative to the ground. So if you have somebody standing there with your radar gun, they would actually clock it at 140 meters per second. How does this make problem solving easier? If we have 60 miles per hour east and car B behind it going 70 miles per hour east, each car's reference frame, the other, has a speed of 10 miles per hour. That means car B rear ends car A, then the collision would be as severe if car B was going 10 miles per hour and rear-ended car A while it was at rest. Now if we have car A going 60 miles per hour east and car B behind it going 70 miles per hour west, each car's frame of reference, the other has a speed of 130 miles per hour. Super dangerous stuff. We go into it more in another video if you are looking for the solutions to those problems. That means if car B rams car A, then it was collision as severe as if car B was going 130 miles per hour and rammed car A while it was at rest. Point is, the physics of a situation is the same regardless of whose reference frame the situation is seen from. So it matters who's doing the communicating, but at the same time it doesn't. Physics is still going to stand. Last lesson we did an example where car A started at 100 meters and went 30 meters per second, while car B started at 300 meters and went 10 meters per second. And then they met on the graph. We solved that problem by creating a different equation, one for each car, and solving the equations together. But what if we just transform into car A's frame of reference? We transform into either car's frame of reference. The cars are still 200 meters apart. But one car is moving 20 meters per second and the other car is at rest. If we can ever get something at rest, that's what we want to do. Because that means something is 0 and we can just cancel it out. So we can just plug in a 0. So we change delta x into v times delta t into 200 times 20 and find it takes 10 seconds for the cars to meet. So much easier to solve a motion problem with two objects if one of them is at rest. Fini.